So today po is mag-solve tayo ng simultaneous linear equation using Python. Problem po natin is find the value of x sub 1, x sub 2, x sub 3 using Gauss elimination method. i-run na po natin ginawa nating program, and okay, nakuha na po natin yung value ng x sub 1, x sub 2, at x sub 3 using Gauss method sa Python.
Hi, I'm Jane Jasmine S. Aquino. Now we're gonna learn how to solve differentiation using Python in Jupyter Notebook. Let's start. So we're gonna import SymPy as SP. So for the SymPy, we're going to create a new variable x which is equal to SymPy.symbol x. Next code, print sp.diff 6 times x squared plus 1 x. I will going to calculate this numerically as well. So from SciPy dot MISC or from SciPy miscellaneous, we're gonna import derivative def f of x so return 6 times x squared plus 1, then print out derivative of f and 2.0. If you want to verify this, we just need to plot this using matplotlib. So percent matplotlib inline, and then import matplotlib dot pyplot as plt, then import numpy as np. So our y is equal to np dot linspace maybe -6 and 6. Then we will create a new plot. So plt dot plot y f of y. Then click run. So the answer in analytic is 12 times x. Since our x is equal to 2, our numeric is 24. Okay, so this is our plot at this function. And as you can see, this is our slope. And if I want,
So hi guys, welcome back again to our channel. On this video, I'm going to discuss about integration in Python using SciPy. But first, let's talk about integration. We already know that integration can be used in so many ways, be it to find volumes, areas, central points, and other things like computing center of mass, center of gravity, mass movement of inertia, and many more. So how do we compute integration? We know that integration is the reverse of finding derivative. That's so easy. Now without further ado, let's get into it. So now we're in our Python Jupyter notebook. Here we need Now we are in our Python Jupyter notebook and we're going to discuss now the integration with Python. Here we need to use SciPy as I have said before. We already have the packages included the library which is SciPy and integrate as the sub-library. To solve the given problem, we will use the function quad as well as all these other packages all throughout the process. So here we have the problem. It says determine the area below f of x equals 3 plus 2x minus x squared and above the x-axis. So yun po. Here we have to put again this one. This is from our library SciPy. Import numpy as np from SciPy integrate import quad. To start our function, we need to input def, then followed with f of x. Then after that, we will also input our function which is 3 plus 2x minus x squared. So yun po. May re-return po tayo na function which is this one. So after seeing the problem, I have set the limits as -1 as the lower limit and 3 as the upper limit. So to get the answer, we have the variable I equals to quad function of f, lower limit, and upper limit. So kung nagwa-wonder po kayo kung ano yung 0, this signifies that we will not get the error in this program. So to get the answer, if we were to run this program, we're gonna get 10.66666. So here we have again these packages. Yes, that one. I'm going to repeat the same process to the which will serve as legitimacy. So here we have again the library SciPy integrate as the sublibrary. To start our function, we have def followed with f of x. Then we have the integrated function, which is negative x raised to 2 plus 2 times x plus 3. And again, I have used the same limits I've used before. And the lower limit is -1, upper limit is 3. Then to get the answer, we have the variable I again and the quad function f, lower limit, upper limit, and the 0 which signifies that we will not get the error. So let's run this program and we get 10.66668 and it's not that far from the first result that we've got. So we know that it is the correct answer. So now that we know that the area below is equals to 32.3. So this is the manually solved version of this problem. So if we are to convert 32 over 3, it is equivalent to 10.666 and something, so on. So let's proceed to get the answer for other functions like other numbers, we need to use this program def followed with f of x, and again use the second one, the integrated one, the simplified one. We are to get a function of 2 equals to 3. We will use this value later for our plot. Then let's move on to this part of the process. We will be able to know that there are so many values under the said area. So to get this, we must print, to get the values, to be able to see the values, we must print x. And then, there you go. We have the value -1, the lower limit, and the upper limit, which is 3. And all these other values will be shaded if we plot the said problem, the said function mentioned in the problem. So here we have import matplotlib.pyplot as PLT. This will help us plot the said function. PLT plot x, comma f of x. Then we have the PLT fill between x and f of x, which is y. Then we have here the alpha equals to 3, the one that we've got here. Yan. Tapos, ayun po. This will serve as the title. So let's see our graph. So there, we have our graph, and this, ayan. Ito yung lower limit, ito yung upper limit. Yan, other values are shaded. So that is the area under f of x equals 3 plus 2x minus x squared. So yun po. To be able to get the said, what do you call this one? The exact, yes. Again, if we are to check with other methods, with other functions, what do you call this? Other inputs, we will still get 32 over 3. Then here, the last one, this is the, what do you call this? The function if we haven't input the limits yet. It is equals to negative x raised to 3 over 3 plus x squared plus 3x. So, yun po ang integration. Everything made simple with Python. Let's scan. Yan na po siya. That's all po. Sana po may natutunan kayo.
Good afternoon. Ngayon po, i-discuss ko paano i-solve yung ordinary differential equation sa Python. So, nandito po tayo sa ating Python notebook. So, nung una, lagyan lang natin yung title natin ng ordinary differential equation Python. Para Jupyter na lang. Jupyter. Okay. Tapos una po natin gagawin ay ang ating header na heading. So meron pa ako ditong notes. I-copy lang po natin yung notes ko ng ating title. Ito po. para hindi tayo matagalan mag-type. Tapos, okay natin. Paste. Tapos po, sa sunod po, lagyan po. Add po ito ng isang level. So, pag add po ng level is Alt, Enter. Tapos, palitan po natin yung ating level ng markdown kasi text lang po yung ating ilalagay. So, punta tayo ulit sa ating notes. Punta tayo sa ito. Copy natin to hanggang dito. Copy. Paste natin ang ating notes. Ngayon po, punta naman tayo sa ating problem. Dagdag tayo ng markdown ulit para hindi tayo malito. Punta tayo sa ating notes. Sana yung problem. Ayun po ang ating problem. I-copy ko muna po bago ko po i-basahin sa atin. Copy. Punta dito. Control V. So, yun po. Nalakalagay na tayo ng heading, markdown, bago natin i-solve. So, ngayon po, babasahin ko po. Ordinary differential equation. An ordinary differential equation or EDU is an equation that involves some ordinary derivatives as exposed to partial derivatives, which we'll be discussing in separate notebook of a function. Often our goal is to solve an EDU, determine the function satisfy this equation. In this notebook, we will be focusing in ordinary differential equation. It is important for engineers and scientists to know how to set up differential equation and solve them. So, ito na po ang ating problem. Lagyan lang natin dito ng problem number 1. Problem 1. Basahin ko lang po yung problem. The concentration of salt X is homemade soup maker is given as a function of time by dx over dt equals 31 minus 3.5x. At the initial time t equals to 0, the salt concentration in the tank is 100 grams per liter. Using the Ronchuk-Colta-Fort order method and as a step size of H equals 2 min, and what is the salt concentration after 3 minutes. So ngayon po, isasolve na po natin ang ating problem. So una po, mag-add tayo ng level. Unang-una po natin gagawin ay mag-import po tayo ng import numpy as np. Tapos from kukunin natin sa scipy dot integrate import odn. Tapos import pa tayo ng matplotlib dot pyplot as plt. Meron pong error. Saan po tayo nagka-error? Enforce. Yung error po natin yung scipy integrated import odn. So, kailangan scipy integrate lang. Kailangan kulang tayo ng R. Natin. Pati yung matplotlib. Nakalimutan natin yung py. Kaya nag-error siya. Ay, dot pala. Kaya nag-error siya. So, yun po. Ngayon po, isa-solve na natin ang ating problem ng equation, may equation na dx over dt equals 31 minus 3.5x. Una po, i-def natin yung function ng t, x. Tapos, enter natin. Enter. Ang XO natin equals to 100. 100. Tapos ang ating H naman ay meron tayong 2. At ang ating T equals to H over 2. Ngayon po, sasolve natin siya. Magsimula tayo sa K1 equals to, yung K1 natin is 31 minus 3.5. 3.5 times natin sa times natin sa x sub 0 natin. X sub 0. Kasi yung K2 natin naman is same pa rin halos na formula. Equals to 31 minus 3.5 times natin sa x sub 0. X sub 0. Tapos ang ating x, tama ba? Wait lang. X sub 3 equals to 31 minus 3.5 times x sub 3. Yung x2 pala natin, meron tayong nakalimutan. I-times natin siya ulit sa K1. K1. Tapos, i-times natin siya sa height na 2. H na 2. Tapos, ang ating 3, yung 3 natin is x sub 0 plus natin ang x sub 0 mali, kalimutan tayo. Minus 3.5 times x sub 0 plus natin ang 2 K2 kanina, tapos nasipan ako K2 times 2 na ating 2. Tapos ang ating K4 equals to, kita natin to kasi mag-error to mamaya. 31 minus 3.5 times x sub 0. Yung K4 is x sub 0 plus K3 times 2 times 2. Ang ating x ay x sub 1 natin equals to x0 plus natin ng cross open parentheses 1 over 6 times K1 plus 2 times natin sa K2 2. Tapos, ipag-plus natin sa 2 times K3. K3. Tapos, plus na naman ulit. Plus K4. Plus K4. Times K4 times H. Doon naman tayo sa ating K, para sa ating isa pang K, para sa ating X sub 1. So, sabihin natin K11 equals to 31.31 minus 3.5 times natin sa X sub 1. X sub 1, di ba? Tapos K12 31 minus 3.5 X sub 1 plus natin yung X sub 1. X sub 1 plus close open parenthesis 0.05 0.5 times ko sa K11 times 2. Tapos yung K13 31.35 31 minus 3.5 times natin sa parang halos same formula lang naman siya, procedure. X sub 1, tama ba? X sub 1 plus 1 tapos plus plus 0.5 times K12 kasi magkasunuran na sila. Tapos times natin yung K12 sa 2. Diba? For K14 na tayo. 31 minus 3.5. Kung makuha natin to guys, madali lang po. Ay, sir pala. X sub 1 plus 13 X sub 1 plus 13 K X plus yung ating K4 yung X sub 1 plus K13 times natin sa 2 close natin to, enter. Tapos ngayon kukunin na natin yung result or return pala dapat, return result. Tapos print natin ang sagot natin na function ng 0 to 100. Siya ay naka-grams. Naka-G per L. Tingnan natin. Add enter. Oh, meron tayong error. Error natin ay sa the function of t and x. Yun. Nakalimutan natin lagyan ng tawag dyan. Semicolon ba? Yan ata. Enter. Unmatch. So, meron tayong error sa K2. K2 natin, dapat ito ay K1. Oh, tama lang. X sub 0 times 2 3.5 times ito ay dapat 0.5 pala dapat to. Tapos 0.5 unmatch ulit yung ating K2. Plus pala dapat to. Ito ata yung mali natin. Dapat plus to. Subukan natin ulit. Error ulit. Yung ating K2. Kulang ata ng isang parenthesis ben. Yun. Sana tumama. Yung 0.5 pa pala. Sa K3. Kailangan dalawa. Yung cross open parenthesis. Tapos ito dapat dalawa lang. Sana tumama na. Tapos yung pangatlo. Kailangan sa mga tayo ng 0. 0. Tapos ito ay dalawa. Tapos yung K13 natin. K13. Ito yung natin. Isa lang. Sa X1 na naman. X1 natin. X sub 0. Yung height niya. Bakit ganun? Ang problema. K4 ay dapat plus. Yun. Mukhang marami tayong error Error pa rin sa X sub 1 natin. Close nga natin to. Tapos 2 plus K ba yan? Dapat siguro ito ay naka-close. 2 times K2 plus ano nga yung error dito? Ulitin ka natin ito X sub 0 plus 1/6 times K sub 1 plus K sub 2 plus 2 plus K sub 2 tapos close Oh, k sub 1 times pala. Tapos, plus. Plus natin sa 2 times k sub 3. Tapos, k sub 3 plus k sub 4 times height h. Sana tumama na. Ay! Does not match outer identification level. Yung print, hindi nag-match. So, ano ibig sabihin nun? Identification error and intent does not match any outer level. K sub 4. Parang dito ata nakakapital siya. Yun. Subukan natin ulit. Alt enter. Sa may print ata yung error natin. Yun pala, close natin to. Tapos ito, bawasan natin ang isa. Saan tayo nag-error? Result. Wait lang. Parang meron pa tayong nakalimutan. Result equals to x sub 1 plus x sub 1 plus 1 over 6 times k sub 11 plus k sub 11 plus 2 times k12 plus 2 times k13 plus k14 times height times h. Close. 1 over 16. Gagawin natin itong dalawa. Sana gumana na this time. Syntax error. Meron tayong error sa ating x sub 1. Ito ay, wala. Ay! Saan pa tayo nagkulang? Lang nga, check natin kung saan tayo nagkulang. Saan tayo nagkulang? X sub 1 k11 times 3.5 def subukan natin itong i-close tapos subukan natin O, yun. Hawak na po natin ang kanyang anong tawag dito, yung kanyang x. Ngayon po, kukunin naman natin yung sa t naman po yung time. So, def x, small, function of t, enter, yung value ng e. Value po ng e ay ito po ay mga constant value is 2.71828. Tapos i-resolve po natin, result equals to 10, mga constant po to, 714 plus 39.286 times natin sa ating 3.5, negative 3.5 times natin sa t, yung value ng t, lagyan lang natin yung t, tapos enter, lagyan natin return result, enter, print value ng x, tapos 3.5 pala, 3.5, tapos comma g by l. Pa natin. Error. Scanning the literal. Saan tayo nagkama? Sa may dito ata. Subukan natin. Yun po. Yung value niya po is negative 470. Okay po. Thank you po. So, ganun lang po i-solve ang ating ordinary differential equation.